Hello everyone, this is Jabal Sonisha. Today I'm going to explain you about my sixth experiment. The first question is to import the necessary libraries and load the dataset. First, we are importing libraries as Pandas, NumPy, Matplotlib, Scikit-learn preprocessing, standard scalar, cluster, agglomerator clustering, matrices, Silhouette score, Davis, Bloden score, and mutual info score. Then hierarchy cluster, importing dendrogram and linkage. Then loading the dataset, giving read CSV, using customer clustering dataset over here, and giving the header value to show the dataset. My second question is to standardize this data. Use standardized scalar for scikit-learn preprocessing to standardize the dataset. For that, I'm just declaring a variable to import standard scalar, and next scalar is going to we are fitting the data frame over here. Then apply linkage and plot dendrogram. First, use a linkage function from sci-fi cluster hierarchy with linkage criterion set to single and distance metric set to Euclidean. Linkage, we are going to set linkage function. Scaled method is going to be single and matrix is going to be Euclidean. Then we are going to plot the dendrogram using the dendrogram function to visualize the hierarchy clustering structure. That plotting figure, dendrogram, hierarchical clustering dendrogram, and giving X label and Y label. So this is going to be our output. Our fourth question is to create clustering models. First, we are going to create two hierarchical clustering model using agglomerator clustering from scikit-learn cluster. Next, vary the number of clusters. Set the distance metrics to Euclidean and linkage criterion to what. So two models, model 2 and model 3. Agglomerator clustering we are using. N cluster is going to be 2 for first one. Second one, it is going to be 3. Using Euclidean and linkage criterion is going to be what. We're going to fit the models and predict the cluster label. We are going to fit the clustering models to standardized data and predict the cluster labels for each data. We're going to do for label S1 and labels 2, label 3. We're going to fit it with X scaled value for model 2 and model 3. Then we are going to visualize the cluster using scatter plot to visualize the clusters, assigning different colors to each cluster for the better distinction. So for that two cluster, we're going to use scatter plot. For 3 also we are going to use scatter plot. For second one we are going to use labels 2, and for 3 we are going to use S3 labels 3, and we are going to plot it with milk and grocery data set, and we are going to find the cluster. So this is going to be the cluster 2 group, and this is going to be cluster 3 group. The next question is to evaluate the clustering performance. Calculate and display the following performance metrics for both models: mutual information score, Szilard score, and Davis Blouin index. For that Szilard score, we are gonna give X scale and label S2 and label S3 for each one. As like previous one, we are gonna give scaled X scale value and labels value for Davis Blouin and for mutual information score, and we are going to printing the values. So this is going to be our output. Our next question is to select the best model based on Szilard score. Compare the Szilard score for the two clustering models. Choose a model with higher Szilard score as the best performing model. Store the predicted cluster labels from the best model in the original data frame for further analysis. So defining a cluster best labels. If the Szilard is SLI2 is greater than SLI3, the best label is going to be labels 2. Else, the better labels is going to be labels 3. Then finding the best, the output is going to be 2 cluster is the best model. And to visualize the data in Tableau, we are going to import the new data frame. After importing the new data frame, we are going to go for Tableau. First, we are going to see the feature distribution, how it is distributed feature, how the features are distributed using scatter plot. The next thing, this is the cluster scatter plot. This is for cluster 1, this is for cluster 0, which is cluster 0 is cluster 2 and cluster 1 is cluster labels 2, which we define there. And at last we are gonna find the milk distribution overall in this question. Thank you.